Making functions continuous. Some functions may not be continuous, but that can be changed. Here's an example. J of x is equal to x squared minus 4, all divided by the quantity x minus 2. This function j of x has a domain of all real numbers except x equals 2, because if we put 2 in, we would get 0 divided by 0, with the main piece being the 0 in the denominator. So in its current state, j of x is undefined because property 1, j of 2, fails because it does not exist. So j of x is not continuous. However, property 2, the limit of j of x as x approaches 2, does exist, and it equals 4. Because that is true, we can define j of 2 to be 4 and make the function continuous for all real numbers. And we can do this by converting j of x from this simple rational function to a piecewise function. So we can create a piecewise function g of x in order to fill the hole that exists in the original function j of x. So this new piecewise function g of x is equal to x squared minus 4, all divided by x minus 2 for x values that are not equal to 2. And then we're going to define it to be k, some number, when x is equal to 2. Now, what should the value of this k be to make g of x a continuous function? Let's actually try to figure that out. We can take our rational function x squared minus 4 divided by the quantity x minus 2, and we can simplify this by factoring the top. That becomes x plus 2, and then times x minus 2, all divided by x minus 2. Notice these two factors cancel each other out, and when we simplify, we would get just x plus 2. Now, if we take the limit as x approaches 2 of this function, we can now use direct substitution for it. That would be 2 plus 2, which equals 4. So therefore, 4 should be the value of k that we need to make this original rational function be continuous. And this slide verifies what we found, that the k value should be 4 for when x is equal to 2 in order to make this function be continuous. And we're filling the hole that occurs with removable discontinuities in rational functions to make it continuous. Let's try another example. Find the value of a to make the function f of x be continuous. We have f of x being this piecewise function and having it be x squared minus 1 for x values less than 3. And it's defined to be 2ax, where a is any number, for x values greater than or equal to 3. And we have to figure out what the value of a is. Let's try it out. Well, we know that both halves of our piecewise function f of x are continuous. We have a parabola for x values less than 3, and we have a linear function for x values greater than or equal to 3. So the concern is making sure that the limit of f of x as x approaches 3 from the left, being from this section, is equal to the limit of f of x as x approaches 3 from the right. Or basically having both of these values, when evaluated at 3, be equal to one another. So the first step in finding this a value is to set the two halves equal to one another. The next thing that we can do is substitute the x value of 3 in for x on both sides of the equation. Next, we can simplify and get 8 on the left and 6a on the right, and then we can divide both sides by 6 and reduce it to find the value of a. Therefore, when a is 4/3, f of x will be continuous.